Hello, welcome back. So now we're on to pricing bonds with spot rates. So what we did in the previous class, we were pricing bonds using the market discount rate or the yield to maturity of the bond. So this means that the same discount rate was used for each and every cash flow. So if we go back to our Riverside retail example quickly, where is it now? There we go. So remember here, we were pricing this bond and we were using a market discount rate of 8%. So each and every cash flow, we're discounting at 8%. So we were getting that back end of year one, and we were discounting that back at 8%. And even this one here, end of year three, that 105, we're getting back end of year three, also discounting it at 8%. And then the same here with the example two, it was just now a semi-annual pay bond, remember? And now the market discount rate per compounding period, that was now 4%. So this cash flow we were getting in 6 months' time, discounting it at 4%. And this last one was end of year three, also discounting it back at the 4%. So what we're going to do now is something a bit different. Let's just go back to where we were. Here we go. What we can do is we can use spot rates to price bonds. And spot rates, they use different so with spot rates, different market discount rates correspond to the cash flow dates. So spot rates then, they are yields to maturity on zero coupon bonds. In other words, a yield on one cash flow only. And we're looking at the maturity on the zero coupon bonds maturing at the date of each cash flow. So let's try this example and it'll clear everything up. So we've got a 3-year bond. Annual coupon rate 5%, and these are the spot rates that we have. So the 1-year spot rate is 2%. So it's also called then Z1, or the 1-year zero coupon bond rate. The 2-year spot rate, it's 2.5%, Z2, or the 2-year zero coupon bond rate. And then the 3-year spot rate is 3%, so or Z3, or the 3-year zero coupon bond rate. So this $5, we're getting that the first coupon back end of year one. So we're going to discount it back at the 1-year spot rate of 2%, or the 1-year zero coupon bond rate. And then the next $5 we're getting back into year two. So we're going to discount that back at 2.5%, which is the 2-year spot rate or the 2-year zero coupon bond rate. And then finally, the big cash flow, the par plus the last coupon, the 105, getting that back into year three. So we're going to discount it back at the 3-year spot rate of 3%, or the 3-year zero coupon bond rate. So now we can see, the different cash flows are being discounted at different rates corresponding to their timeframes. Now, a lot of people like this because because that we know that the cash flow we're getting back into year one, there's going to be less risk attached to it because there's a shorter time to wait for this cash flow into year one. So we can discount it at a lower rate because there's less risk. And this cash flow only getting back in 3 years' time. In 3 years, the more things can go wrong with the company. So there's going to be more risk attached. So we should therefore, it's a good idea to discount it at a slightly higher rate because there's a little bit more risk attached in getting the final cash flow compared to getting the first one. So all then we do is we do our 3 separate little present value calculations, and that gives us the price of the bond. And unfortunately, we have to do 3 separate calculations. We can't use the time value of the time value of money buttons anymore in the calculator because the interest rate is changing every time. Anyway, so we've done that there. We've worked out the price. Now what we can do is this. We've got the bond price, the 105.75. Now we can calculate the market discount rate or the yield to maturity, which remember is an internal rate of return. So there is the bond price. And remember what an internal rate of return is from the previous class. It's the discount rate that makes the present value of these cash flows equal to the bond price. And like we discussed. So all we need to do then is plug in our numbers on the calculator, and we work out our IRR is 2.97%, or that is the yield to maturity of the bond. Or we can use the cash flow buttons now. And I highlighted there again there in red that we must use a minus sign for the present value because these cash flows are going in opposite directions like we discussed in the previous class. And we also then get 2.97%. So we can use either method. Right, so now what we can see is that this is a premium bond. So it's going to make sense that the coupon rate, it's the 5%, it's greater than the yield to maturity, because remember with a premium bond, the coupon rate is above the yield to maturity. So another way to look at the yield to maturity is that it is in fact a weighted average of the underlying spot rates from the previous slide. So it makes sense that in our example, the yield to maturity is 2.97% because it's going to be very close to the 3-year spot rate, which is 3%. So it's going to be very close because the 3-year cash flow, it's by far the biggest because it's got the par value at the end plus the coupon. It's going to be 105. So the yield to maturity, it's always going to be slightly less than the final year spot rate. So if we just go back quickly and just double check that. So it's going to be a weighted average of these, the 2%, the 2.5%, and the 3%. But because it's a weighted average and the 3-year rate has got by far the biggest weight, the 105, it's going to be very close to 3%, but just a little bit less because 2 and 2.5% are less than 3. So it's going to bring this down a little bit to 2.97%. So if they ask us on the exam, what's the yield to maturity? And there was one answer that's just less than 3%. We can just go straight for that one and not work this out first and then have to work all this out, because they love to ask those conceptual things on the exam. So we need to be aware of those types of things. Excellent. Right, now we're going on to the flat price, accrued price, and the full price. So let's see what we've got here. So when a bond trades between coupon dates, which is going to be most of the time, because coupon date is only once or twice a year, so the rest of the time it's going to trade between coupon dates, then the buyer, who's the new owner of the bond, he or she is going to get all of the next coupon payment. Why? Because the buyer is going to be the registered owner of the bond, and whoever the registered owner of the bond is, he or she gets all of the next coupon payment. So we have a little bit of a problem here, because the seller he's entitled to the interest earned from the previous coupon date to the date of sale. And that's what we call the accrued interest. So this means that the buyer must pay this amount to the seller because the buyer is going to get the full coupon, but the interest that the seller is entitled to, the buyer must give this to the seller. So let's try this example and we'll see how it works. So Vuyo, he buys a $100 par value bond, annual coupon 5%. And the coupon is paid on 30 June each year, and the order settles on 20 October. So this means that the bond is going to be registered in Vuyo's name on 20 October. So here we've just got a little timeline. So the first coupon date here is going to be 30 June, let's call it 2001. And then a year later, another coupon will be paid because it's annual coupon, let's call it 30 June 2002. And now Vuyo's order, it settles here on 20 October. So that's when the bond is registered in his name. So this means that the seller of the bond is entitled to the interest for this period of this coupon, of this 30, oopsie, I've made a bit of a mess there, of this coupon here. The seller is entitled to the interest over here of that 30 June 2020 coupon, 30 June 2002 coupon, I beg your pardon. And that's what we call the accrued interest. And this now means that Vuyo, he is entitled to the interest of this coupon. He's entitled to that interest from here, from 20 October 2001 to 30 June 2002. So let's do the maths quickly. So the total coupon, nice and easy, we know how to work that out. The total coupon, it's $5. So this means that Vuyo, he will receive all of this coupon payment on 30 June 2002 because he is the registered owner of the bond. He's going to get the full coupon. So to work out the accrued interest, what belongs to the seller, that we need to, there's two ways to do it. we can use the 3360 method or the actual method. So let's do the 3360 method first because it's nice and easy. So now we assume that each and every month has got 30 days, even if it doesn't, and the full year has only got 360 days. And we mostly use these for corporate bonds. So the days that the seller is entitled to the interest, which is called the accrued interest, we got to go here from 1 July there all the way to 20 October there. So we've got to take July, and every month has now got 30 days according to this method. 30 days for July, 30 for August, 30 for September, and 20 days for October, right? So because the bond was registered in his name only in 20 October, so the seller is entitled to 20 days of interest for October. So that's 110 days. So now we can work out the accrued interest. It's 110 days. The total time is 360 days. So it's going to be $1.52. That is the accrued interest. Now, Vuyo, the buyer, he must pay this amount to the seller. So if the quoted price, or what they call the flat price of the bond in the market, it's $102. This means that the full price is as a full price now. This now includes the accrued interest. Or they also call it the invoice or the dirty price. So all we do is we take the flat price, or we call it the quoted price if we want to, or even the clean price, and we just add that accrued interest to it. So that would then give us a total of 103.52. That's the full price. So why do they quote in the market the flat price and not the full price? The problem with the full price is that if the full price was quoted over here, the 103.52, then that would actually be misleading, because the price would go up each and every day as the accrued interest increases, or because the accrued interest goes up a bit every day. So then the bond price will be going up every day due to accrued interest, not because the issuer's credit quality is improving. So that's why we rather use the flat or the quoted price in the market. Right. So now the sorry, beg your pardon. I just wanted to mention one more thing. I was just thinking of it. I've got it now. So another way to say it is that the full price includes the accrued interest. Okay, dokes. So now let's try the actual method, which is a bit of a pain, because now we're going to use the actual number of days are used. And this, we mostly do these for government bonds. So now what would be the days the seller is entitled to the interest? We got to use the actual number of days. So it's going to be how many days in July? Actually, 31. How do we remember that? So you might remember, I'm sure you did this at school. So if you take your knuckles, start on the left, January, if it's a knuckle, it's 31. And then if the next month, February, it's going to be a valley, it's going to be, okay, we know February's got 28, but otherwise a valley is 30. The next one, March, is a knuckle, so it's going to be 31. And April is a valley, so it's going to be 30, etc. And if you don't know that method, I'm sure if you can ask somebody who does know about it, they'll tell you. So anyway, the exact number of days in July is 31, in August is 31, September's got 30 days, and there's the 20 days of October, so it's 112 days. So now the accrued interest then would be $1.53. So I'm quite sure if it is on the exam, we're going to work out days. I'm sure that'd give us a bit of leniency, because you'd probably find if they wanted us to work out accrued interest, let's say the using 3360 method, exact answer we worked out at 152. The next correct answer choice, say, may be 160, and another one might be, say, 140. So we might be, say, closest to, even if we're a day or two out. So I'm sure they give us a little bit of leniency if they do want us to calculate the number of days. Right, so let's try another example then. And before doing this example, I suggest making a strong cup of coffee, or maybe something better, maybe pour a nice whiskey or something, because this is a bit hectic. But anyway, we'll go through it. I don't think something like this would be on the exam, but we need to do one of these because I see there was a CFA Institute practice problem like this. So that's why I've done one as well. So let's see. Well, let's give it a go. So we've got Sarah. She buys a bond for settlement on 15 September 2020. So that's when the bond is going to be registered in her name. So the bond has a coupon rate 5%, semi-annual payments on 30 June and 30 December each year. And the maturity of the bond is 30 June 2025. and the annual yield to maturity is 6%. So they want us to use now the 30-360 method. Thank goodness, that's because it's easier to calculate the full price, the accrued interest, and the flat price per 100 of par value. Sure, let's give it a go. So what we've got to do, if we got a question like this, step one is always find the value of the bond on the last coupon date before the bond is sold. So the bond is sold here in September. So the last coupon date before the bond is sold is going to be 30 June 2020. So what do we need to do? We need to find the value of the bond on 30 June 2020. So from 30 June 2020 until the bond matures, which is 30 June 2025, that's 5 years. So how many periods are there in 5 years? Well, there's 10 because it's a semi-annual pay bond. There's semi-annual pay bond. So it's 2 periods a year for 5 years, total number of periods 10. And then the payment or the coupon, it's 5%. So it's $5 a year. So it's going to be $2.50 every 6 months. And the interest rate per compounding period, so they gave us there 6%, the discount rate 6%, and it's going to be 3% then every 6 months. That's the interest rate per compounding period. And we know the future value is the par, what we get back, $100. And there we hit the present value. So now what we've got is this. This is the value here on 30 June 2020. And we need, this is the full price of the bond on 30 June 2020. And what do we need? We need the full price of the bond on 15 September. So we need to compound this a bit up to get the value on 15 September 2020. And this is how we do it. So I drew the diagram again because this helps a lot. So we got a coupon date over here, 30 June 2020. So the next one's going to be 30 December 2020. And this is when the settlement date is 15 September, when the bond is registered in Sarah's name. Right, so this means that the seller is entitled to the interest of this coupon up here. The seller is entitled to the interest of that coupon from 30 June or from 1 July over there to 15 September 2020 over there. And then Sarah, she's entitled to the interest of this coupon. She's entitled to the interest here from 15 September from when the bond's in her name up until 30 December 2020. And then the total days in the coupon period, which we call uppercase T for our formula coming up in a minute, that is going to be 180 days because we're using the 30-360 method. So fortunately, it's nice and easy. Every month has got 30 days. So now the days from the last coupon period to the settlement date, which we call lowercase t, that's the accrued interest period. So in other words, from there, from 1 July there to 15 September over there. So every month has got 30 days. July, August got 30 days and 15 days of September. So it's going to be 75 days. That is the interest then that belongs to the days of interest that belongs to the seller. So now what we need to do is we need to compound the value of the bond on 30 June 2020. That's what we worked on the previous slide, that $95.73. We need to compound that value by the annual yield to maturity, which they gave us was 6%. So on a 180-day basis, it's going to be 3%. And we need to do this now for the 75 days of the 180-day coupon period. And that's then going to give us the full price of the bond on 15 September. That's what we want. That's what we need to work out from the question. What's the full price of the bond? So to get the present value of the full price, we take the present value on 30 June 2020, we worked on the previous slide, was 95.73. Now we need to compound that up a little bit by that 3%, but we compound it for what period of time? From lowercase t was the accrued interest days, the 75 days, and the uppercase t, that was the total days in the compound, total days in the coupon period, which was the 180 days. So our N, or our compounding period, is going to be 75 days of the 180-day total period. So there we go. Now we've got the present value of the full price. Okay, that's the full price. Now, remember what the full price does? It includes the accrued interest. So if we want to now see what the flat price is, we've just got to take out the accrued interest. So we know how to do the accrued interest. This is not this is the part that's not so bad. The coupon we know is $2.50. So the accrued interest, it's 75 days of the total 180-day period. It's $1.04. So this means now that the flat price or the clean price, that is now the full price excluding the accrued interest. So we take out the accrued interest from the full price we worked out on the previous slide. And this means that the flat price or the clean price is $95.88. Sure. So I told you to pour something strong because this is a bit of a hectic example. So I don't know if they'd ask us something so complicated on the exam. Maybe they could give us the full price and be kind. And we might then have to maybe only work out the accrued interest. And if once we've done that, we can take out the accrued interest and then get the flat price, for example. Let's hope it's something like that. But here is the bad news. Remember the addition to the CFA Institute practice problem solutions that I've done? There was one of these questions. Where is it now? Here we go. This question, we had to do one of these like we've just done. And I've done it on exactly the same basis. Right, just only thing that's really changed is numbers. So have a look at that, and you'll see I've done it in our way, which I think will assist. So here we go. I'm sure we'll be okay though. So I think everything's going to be all right. Good. So now we just need to look at one thing, and that is one more thing I should rather say, and that is the matrix pricing. And matrix pricing, this is a process used to estimate the yield to maturity or the market discount rate of a bond that is infrequently traded. So let's just stop there for a second. If a bond does not trade, then it's not going to have a market price. And if it doesn't have a market price, then we can't work out the yield to maturity. So what are we going to do? How are we going to work out the yield to maturity then? What we're going to use is we're going to use bonds with similar credit quality. So if we are trying to get the yield to maturity, let's say on a BBB bond, then we'll also use bonds that have got BBB ratings to estimate the yield on our bond. And term to maturity, we want that also to be similar. And we're going to see how it works now in this example down below. And we also want similar coupon rates that do not act and coupon rates. So we're going to use those bonds that actually do trade actively, and if they trade actively, they're going to have yields to maturities, and we'll use those to estimate the yield to maturity of our bond that's not trading. So let's try this example. We'll see how it works. So we've got Fab Ferns bonds. They are not frequently traded, and they are 5-year bonds. And we need to use the following bonds that have similar credit quality. So let's say, for example, Fab Firm is rated BBB. So we'll use other bonds that are also rated BBB, and we'll use those bonds to estimate the yield to maturity of Fab Firm's bonds. So we've got here a 4-year bond, and it's got a yield to maturity of 6.2%. And we've got a 7-year bond that's got a yield to maturity of 7.7. Now, the problem is that Fab Firm's bonds are 5-year bonds. So we need to now interpolate what they call interpolation, use interpolation to work out what would the yield be on a 5-year bond. So we just ignore this box for now. I just want us to look at something here. What I'm drawing now is what we call the yield curve, which we're going to do in a lot of detail in a class or two's time. So we've got time on the horizontal axis and yield to maturity here on the vertical axis. So what we're going to do is see here, this is going to be an upward sloping yield curve, which there are most of the time, because we've got the 4-year bond over here. The 4-year bond is over here, and its yield to maturity is 6.2%, right? So we put there like that, 6.2%. And then we've got the next one, which is the 7-year bond. It has the 7, let's put in 7 years there. Its yield is over here, 7.7. Right, so I just put in there 7.7. So what we need to solve for is this. Fab Fern's bonds are 5-year bonds, right? So we need to use the 4-year rate and the 7-year rate to try and interpolate, what is the 5-year rate going to be? It's going to be somewhere in between over here. And this makes sense, like we've discussed before, and we'll talk a lot about this also in other classes, is that the longer the term of the bond is, the higher the yield should be, because there's more risk the longer out, the longer or the further out we go in time, because there's no more can go wrong with the company. Shorter terms, there's less risk, right? Because you're going to get the money back earlier. So anyway, for this, I just want us to now look at this box here. So let's say, if, we're not saying there are, but if there were now 2 or more similar 4-year bonds, we would then just take the average of the yield to maturities of the two. So let's say there we got one 4-year bond has a yield to maturity of 6.1%, and another one has a yield to maturity of 6.3%. The average of the two is 6.2. So if we had 2 bonds, we could then, that are both 4 years, same credit quality, we would use that 6.2. But here we're just saying we have one 4-year at 6.2 and one 7-year at 7.7. So now to work out, what will the 5-year yield be? There's a few ways to do it. And this is the way I like the most, because it was actually shown to me by somebody a few years ago, and I've liked this way ever since the best. So let's give it a go. So the difference between the 7-year bond and the 4-year bond, we got a 3-year difference over here. And that 3-year difference is 1.5%. But what we need is a 1-year difference, because we want to go from 4 years up to 5 years. So the 1-year difference is going to just be 1.5 divided by 3, because this was a 3-year difference. So it's going to be, the 1-year difference is going to be 0.5%. So the difference is going to be the same every year, because we are doing what we call linear interpolation. So for every year we go 1 year further out, the yield's going to increase by 0.5%, because then of the extra risk as we got longer terms. So now to work out the 5-year yield to maturity, all we need to do is take our 4-year yield to maturity, which was 6.2, and then add this 0.5% onto it. And that's all it is. So then the 5-year bond, it works out here at 6.7%. So we can write in the 6.7% over here. That's what the 5-year would be. So if they ask us this on the exam, what's the 5-year yield to maturity, and they give us a 4 and a 7-year, well, the 5 years got to be in between, somewhere in between. So if they only give us one answer choice in between, we'll just go straight for that one. We won't have to work anything out. Let's hope if it's on the exam, it'll be something like that. Okay, dokes. Now, what happens if Fab Fern's bonds, what happens if they were 6-year bonds? What would we do then? Well, then we would just take the 5-year yield to maturity, which we worked out was the 6.7% over there. And all we need to do is add on 0.5% for the extra year, which would give us 7.2% if it was a 6-year bond. Or I guess what we could have done is, if it's 0.5% for every year, 6 years is 2 years away, so it's 1% for 2 years. So we could add on 1% to the 6.2. 6.2 plus 1 would also give us 7.2. So that would be another way to think about it. So anyway, that takes care of that. So we can see here that what we need to do is practice a lot of questions, and then it really will improve and get a lot better. So just study hard, put in those hours, and we'll see you guys in the next class. Hello, it's Tim here again. I hope you enjoyed the class and found it beneficial. We have some classes available for free on YouTube, but we have classes for the entire curriculum. The classes that are not on YouTube can be purchased from us. If you'd like to purchase the classes, please contact us for the pricing, and I've put our contact details over here. You can purchase all the classes or certain readings that you would like. When you purchase the classes, we provide you with the slides and our notes. I've assisted hundreds of candidates pass CFA exams, and I look forward to also helping you through the CFA program. I've put in 2 testimonials in the slide over here, and we also have a testimonials page on our website that you can review. I look forward to seeing you soon, and all the best.